Right, continuing on with our section 1 videos, remember the interior angle sum formula for any polygon, doesn't matter how many sides there are. If we want to know the sum, so add up each of these angles together, we want to find out how much they would equal together, you just use 180 times the amount n minus 2, where n is the number of sides. So if there are 7 sides, you do 7 minus 2 and then times 180. In this case, you would say, well, there are 6 sides here, so 6 minus 2 and then times 180 would be all of these added up. Okay? Another thing to remember, the exterior angle sum, all of these exterior angles, these angles are the ones on the outside here, so this angle, this angle, this angle, if we added up all of these, okay, even if it wasn't necessarily like a regular polygon, all of these outside angles have to add up to 360, no matter what, every time. Now I'm going to show you a table that I created here. You don't have to write this down if you don't want to, but if you want to put this in as kind of a reference so you can use it on your homework, that is just fine. I have a table made where I took my n number of sides. I can find the sum of all the interior angles. Remember, we just said that's 180 times n minus 2. If I wanted to find one interior angle, and that was of a regular, so one regular interior angle, I would have to use the formula 180 times n minus 2, all of that divided by n. And that would be, remember, the sum of our interior angles, so all of these added up, divided by however many there are. So if I know that there are n amount of angles in here, I would just be dividing by n to find out how big one of them is. Now I can simplify that formula right there to say this piece right here, 180 minus 360 divided by n. So this would be the measure of just one inside angle. Okay? The sum of all the exterior angles for everything is always going to be 360. So no matter how many sides there are, there could be 7, there could be 12, there could be 23, all of the outside ones will add to 360. So if I wanted to find just one outside angle and it was a regular polygon, so all of the angles were the same, I would do 360 divided by n. Now one thing I want you to notice, a regular, well, not even necessarily if they're regular. If I have these two angles here, and I said that this was my exterior and this is my interior, then these two together have to add up to 180. So if I know how big my exterior, this one over here, is, I would do 180 minus my exterior to find the interior angle. Okay, so look at how that fits here. I know how big an exterior angle is. I do 180 minus however big that exterior angle is to find my interior. Okay, so that's why all of these things kind of match up. So let's check how that works for some of our actual pieces. If we have 3 sides, so a triangle, all of them have to add up to 180, and we know that for sure because we plugged it into this formula, and we just know that about triangles. They all have to add up to 180. So if all of the sides were equal, like if we had an equilateral triangle or a regular triangle, each inside angle would be 60, and we know that too. That has to be true. All of the outside ones are 360, so 360 divided by this 3 right here would be 120, so that part fits. Now notice how 60 plus 120, if we paired those together, those add up to 180. So those all fit together. Okay, let's check a couple more. 4, so if we had a quadrilateral, 4 put into this formula, 4 minus 2 is 2, 2 times 180 is 360. This piece right here. 360 divided by 4 means that each corner has to be a 90-degree angle. Okay, so in a square, that would be a regular quadrilateral, would be a square. Each of the corners is going to be 90 degrees. And they are. We know that for sure. So that one fits. Same thing if we look at exterior angles. Well, our exterior angles are always going to add up to 360. 360 divided by this 4 would be 90. So this would be the measure of each exterior angle is 90 degrees, and 90 and 90 add up to 180. So all of our exterior angles will always add up to 180. All of the just one regular exterior angle times however many sides there are would give us 360. One of our interior angles times however many sides there are would give us the sum. So that's how all of these things kind of match up. Everything kind of fits together in one. So if you want to write this table down, you can. You don't have to write this reference table down, but it might help on the homework. And if you want to extend it, give it some more boxes, say like 9 sides or 10 sides. Go on. I only went down to 8 sides, but if you want to make it bigger, you definitely can. So I'm going to move on from there and look at some examples. So for this example, here we have a figure, and we continued on the sides here to make some exterior angles. We want to know the measure of angle QXZ. So that's this exterior angle right here. Well, remember, the exterior angles all added up have to be 360. So if we do this exterior angle, 70 plus 60 plus 65 plus 40 plus whatever this angle is right here, all of this has to be 360. So if we simplify it down, all of these add up to 235. If I take away 235 from both sides, so 360 minus 235 should leave me with QXZ. So I'm going to get rid of this. QXZ is actually going to be 125 degrees. So this piece right here. Okay. The question is, what is the sum of the interior angles of this polygon, RQXVT? So R to Q to X to V to T. Well, there are 5 points here, 5 letters. So if there are 5 points, there would have to be 5 different sides. So there are 5 different interior angles. Well, either we can go through the process ourselves, do the 180 times 5 minus 2, or if you had that table down, we can just go down here and say, okay, for a 5-sided figure, all of them have to add up to 540. So let's see if that came true. 5 minus 2 is 3. 180 times 3, 540. So our table is correct. Okay, so here's 540. All of these added up have to be 540. So now we need to know what is the measure of each interior angle of the polygon. To know the interior angle, we have to subtract the exterior from 180. Here is a line going right here. So the line is 180 degrees. 125 degrees is right here. So we'd have to subtract 125 to find this one. Well, 180 minus 125 is going to be 55. So this piece is 55. Same thing, 180 minus 70 is 110. So this one becomes 110 degrees. Here's our straight line. 180 minus 60 degrees is going to be 120. So this interior angle is 120. Here we have another straight line. 180 degrees minus 65. This angle right here is 65. So it would leave us with 115. This angle right here. And this little one right here, it's got a really little side. But going from here to here, this angle, we would say, if here's our straight line, we've got 40 degrees right here. So 180 minus 40, this angle is 140 degrees. So each of these pieces, these are the interior angles then of our pentagon. So then we can check and make sure. We know that it's supposed to come up to 540, so we would say 540 is how big it's supposed to be. Now we'll just match each of those and see if they actually check out. 55, 140, 115, 120, and 110. If we put all of those right here, do they actually add up to 540? Well, yes, actually they do. They'll all add up to 540. So this is double checked. They all make sense. Now for number 4, we have a figure given here. And they told us that this line right here is parallel to this line. We know that because they have this mark right here, this little arrow, that means that they are parallel lines. Okay, if these two are parallel lines, then that means this line going across here, this is the transversal. Okay, so one thing we can say, if we look at this line right here, W plus 110 has to be 180 because that is just a straight line. So W plus 110 has to be 180 because they're a linear pair. So that's one thing we know. We can find W from that. If this line, oops, one like that, if this line is the transversal cutting it across, then W and X are corresponding angles. And since the two lines here are parallel, parallel lines imply that corresponding angles are equal. So we can say that X has to be just as big as W, so W equals X. The same way, Y right here corresponds with this angle, 110, so we know that Y has to be 110. And these two right here. Okay, again, if we have the two angles, or oops, the two lines being parallel to each other, and we have this transversal, I'm going to use a straight line to draw it out. Use blue. If this is the blue transversal cutting these two parallel lines, these two angles would be same side interior angles. And we know that same side interior angles of parallel lines have to be supplementary. They have to add up to 180. So we'd say Z plus 90, because this is a right angle, Z plus 90 equals 180, because parallel lines imply that the same side interior angles are supplementary. So now we'll just figure everything out. W plus 110 equals 180. So 180 minus 110, W has to be 70. If W equals X and W is 70, then X has to be 70. Y equals 110, because it's corresponding, so 110. And Z plus 90 equals 180, so Z has to be 90. Perfect. Example 5, given a regular heptagon, so that's a 7-sided figure, what is the measure of one interior angle? So if all of these are the same length for the sides, all of these angles are the same measure, because it's regular, what would be the measure of just one of them? So this is what we would use. This is the formula to use to find the measure of one interior angle of a regular polygon. Okay, remember we used the sum of all of them. So how would you find each of these added up? This one plus this one plus this one, and so on. All of these added up together, that would be that piece over there, the 180 times n minus 2. Okay, once we know how big all of them added up are, we can divide by however many there are, n, to find just one. So we plug in 7, because there's 7 of them. 7 minus 2 is 5. 5 times 180 is 900. So all of these blue angles here added up have to equal 900 degrees. So then 900 degrees divided by 7, because there's 7 of them, means one of them would be 128.57 degrees. Now let's check. If you had that table, if you wrote that down, we can check and be sure. We go to 7, heptagon, and we want a regular interior angle, 128.57, matches up with our 128.57. Perfect. So our table is coming in handy. Example 6. If a figure has an interior angle measure of 135 degrees, can it be a regular polygon? So we don't know how big our polygon is. I happen to have drawn a heptagon, a 7gon, but what they're telling us is if one of these angles is 135 degrees, can this actually be a regular polygon? If so, what polygon would it be? If not, why not? Okay, so what we need to set up here is a formula or an equation that sets the sum of our interior angles equal to the sum of our interior angles. Well, the sum of our interior angles, remember, is always 180 times n minus 2. The sum of our interior angles, because it's regular, would be this piece, 135, times however many sides there are. So we'd set these two equal to each other. Okay, moving on from there, now that we set them both equal to each other, we can distribute. So 180 times n, 180 times -2, and we'd get 180n minus 360 equals 135n. At this point, we can subtract 135n from both sides. That leaves us with 45n minus 360 equals 0. From there, we can add 360 to both sides. That'll cancel out this piece. So 45n equals 360. To get n alone, we would just say divide by 45 on both sides, and we'd get n equals 8. If this fraction, or this number right here that we got, was a decimal or a fraction, then the figure could not be a regular polygon. That would mean that there would be like 8.5 sides or 3.5 sides, and that doesn't make sense. So if this number has to be a whole number for it to be a regular polygon. Since n in the end equals 8, we would say, yes, this can be a regular polygon. It would be an octagon. And if you can't remember octagon, you just call it a 8gon. Okay? Now again, they told us that it'd be 135 degrees is the measure of one interior angle, and that would make an octagon. So let's check with our table one more time. If you made this out, octagon, 7 or 8 sides right here, one regular interior angle will be 135 degrees, and that fits with our table. So if you got an extra sheet of paper, or you can write small on your notes, fill in this table, and that'll help you. And if you want to extend it, put on some more sides, that's not a bad idea.